So where does the number 1.660540 times 10 to the negative 24th actually come from? And the answer is it represents the actual mass of hydrogen. And so this brings up this idea of what are AMU exactly. And so scientists decided that 1 AMU should represent 1/12 of the actual mass of a carbon-12 atom. And so they picked this because carbon-12, or the isotope carbon-12, has 6 protons, 6 neutrons, and 6 electrons. And so they figured that this is the best way to average together what a single atomic mass unit should actually represent. And so now as we look at the periodic table, is the mass of sulfur, or a sulfur atom, actually 32 grams? And so let's pull up our periodic table and notice sulfur down here with the atomic number of 16 has the mass of 32.06. And so this 32.06 doesn't actually represent the mass of a single atom. It represents the mass of a mole of sulfur. Now, moles are something we're going to talk about later on. And so what this really is saying is that 32 grams for one atom is just incredibly large. In fact, it's way, way, way too much. But sulfur overall is 32 times heavier than hydrogen. And so what that means is that all of the atomic masses on the periodic table, which are given in AMUs, and all of these AMUs are relative masses, which means that the periodic table masses can be used as comparisons, and these show the relationships between the actual masses, which means that these show the relationships in grams. And so the key here is that the periodic table is showing AMUs, but we can use AMUs to show or determine the relationships between different masses. And so when we're looking at kind of going from this, what is the actual mass in grams of a sulfur atom? Now remember, we know the actual mass of a hydrogen atom, and so we can actually calculate the mass of any single element. And so remember, we mentioned it earlier, sulfur is 32 times heavier. Yes, you will need your calculators. And so since sulfur is 32 times heavier than hydrogen, let's kind of go through this. And so if we take our mass and we're just going to round to 2 decimal places, 1.66 times 10 to the negative 24th grams, and multiply it by 32, since sulfur is 32 times heavier according to the periodic table, what we actually end up getting, let's do some number crunching here. We get the answer 5.312 times 10 to the negative 23rd grams. And so now let's look, how do the actual masses of hydrogen and sulfur compare? And so since sulfur, according to the periodic table, is bigger, we're going to put sulfur on top of our fraction and hydrogen on the bottom. And as we compare, we'll put 5.312 times 10 to the negative 23rd grams over our 1.66 times 10 to the negative 24th grams. Now, when we divide this, we should end up getting 32, which, remember, means sulfur is 32 times heavier than hydrogen. So let's look at another example. How do the masses of nitrogen and lithium compare? Now, remember, nitrogen is heavier than lithium. And so when we divide this, we set it up as nitrogen over lithium. Now, when we look at the periodic table, nitrogen has a mass of 14, while lithium, on the other hand, has a mass of 7, which means in this case, when we divide this, we get 2 times, meaning nitrogen is 2 times heavier than lithium. And then finally, this brings up our last example. What is the actual mass of a fluorine atom in grams? And so remember, the mass of a single atom is 1.66 times 10 to the negative 24th grams. Now, when we look at the periodic table, it's actually like 18.99, and we're going to just round that to 19. And so we're going to say 19 times our 1.66 times 10 to the negative 24th. And what we end up getting is that the actual mass of a fluorine atom is 3.154 times 10 to the negative 23rd grams. And so remember, this represents the mass of a single fluorine atom. All right, hopefully you guys enjoyed class, and I will see you all tomorrow. Bye, guys.